this whole time we were finding probability. Well, we want to find, what if we want to find values of x instead of the probability? We're going to do something called inverse. So for inverse, it's in distribution, number 3, inverse norm. And you see it's asking for the area. It's asking for the probability, the percentage there, and then the mean and standard deviation. And I'll show you what this means. So in this one, they're saying a person scores in the 45th percentile. What score did he have? Well, think about when you take the SAT, when you score, if you get like the 60th percentile, 70th percentile, you're okay. Don't make the mistake like I had a student one year who got in the first percentile and thought that was, she was at the top. No. That means you're at the bottom. That means 99% of the people did better than you on the test. So we have our x-axis here. It says a person scores in the 45th percentile. Well, my mean is right here in the middle. I don't know what my mean is, but I do know that I'm going to have a curve like this. And 45th percentile, what that means is you did better than 45% of the students, not the other way around. You did better than 45% of the students, which means 55% of the people did better than you. So the 45th percentile would be, if I have, this is the mean, 1 standard deviation, 2 and 3, 1, 2, 3. 45% would be somewhere between, so think about it. If this is our mean, this is where 50% is. That's 50%. 45% will be here somewhere. So we're saying, I want to know if this person scored better than 45% of the people, what score would you have? We want to find out what score goes here. That's what you use the inverse norm for when you find the x value. So this one goes with the last question. The mean was 100 and standard deviation was 10. So I'll write 100 here. And then right here would be 90 because it's down 10, which means that score is going to be somewhere between 100 and 90. And that's what we're going to use inverse norm for. So this area, this is 45%. 45%. So the area, that's going to be 0.45. Our mean is 100. Standard deviation is 10. And we put that in our calculator here. 0.45. Go down 100, 10, and then we're going to get a score. That means this score, to be in the 45th percentile here, you had to score at least, this is a 98. So the probability of scoring better than Maria on the IQ test. So it's the same problem. So we have, the mean is 100. Notice the probability of scoring better than Maria on the IQ test is 0.30. That's 30%. So remember, if we start here in the middle, it's supposed to be the middle, sorry. This is 50%. So 30% would be somewhere here. Because right now, for this part, put it somewhere like right here. We don't know that yet. This doesn't have to be accurate. So this is supposed to be 30%. So then what will we put in for our area? If we want to find this value here, we have to find this always by using the left side. So if that's 30% on the right side, this is going to be 70%. That's what we use for area. And so when we type that in here, we'll say 0.7. There we go. And so don't mistake this for your percentage. That's not your probability. That is your actual score. That's your x value. So you see here, I got my area where it was wrong. So it actually should be right here, but that's okay because my calculator told me the right answer. So I'll be going down here. So it's about 105. And so yeah, so inverse is for finding x value on the x-axis. The regular norm is for finding the percentage, the probability.